All right, guys. Today I want to talk just a little bit about our graphs. So if you look in this picture right here, I have a little graph drawn, and what I want to do over here is fill in my adjacency matrix. So here I have this left side of my matrix labeled as source, and over here I have it labeled as destination. The adjacency matrix shows direct connections between the vertices of the graph. So all I really have to do is where I see a direct connection, like let's start here at 0, I have a direct connection to, well, only to vertex 1. So I'm going to put a 1 right there. Now when I go to vertex 1 as the source, I only have a connection to vertex 2, so I put a 1 there. When I go to vertex 2, I only have a connection to vertex 3, so I put a 1 there. Now on vertex 3, I have connections to this big loopy one to 0, like that, and I have a connection to vertex 1. Now, there are no connections on any of these other guys, so really we can put in a 0 for each one of those. I'm just going to pencil them in very lightly here because sometimes it's easier to look at the matrix with just the ones. Now, looking at our graph over here, you can see that I have arrows on each one of these edges. That means it's a directed graph. There's a cool thing about an undirected graph. Let's just make another graph real quick. I'll get it like this: 0, 1, 2, and 3. Boink, 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 boink. And how about this? Whoop, all the way around like that. I don't know what that looks like. It looks like a bug or something. Anyway, ooh, thought I saw a bug. Okay, hang on. Don't scare me. So let's do our adjacency matrix. We have 3 vertices: 0, 1, 2, 3. Like this. I don't usually do them quite this detailed. Usually I write them down more like a matrix in math. 0, 1, 2, yep, get this last bit, 3. Now, these edges aren't directed, so that means they actually go both directions. And we'll see that that's going to give our adjacency matrix an interesting property. So here we go. We have connections from 0 to 1. So I'm going to put a 1 there, and we have another connection going from 0 to 2, so I put a 1 there, and I have another connection going from 0 to 3. Let's see. Now I go to vertex 1. I have a connection from 1 to 0, because remember, this goes both ways. Then I have a connection from 1 to 2, so I put a 1 there, and I have a connection from 1 to 3, so I put a 1 there. Now, vertex 2, I have a connection from 2 to 0, like that, 2 to 1, like that, and 2 to 3, like that. Am I getting that right? Looks right so far. Now let's see. Vertex 3 looks like it's connected everywhere. 3 to 0, there. 3 to 1, there. And 3 to 2, there. Now, this isn't the greatest example, but you can see, if you look at this closely, you see a symmetry about the diagonal of this adjacency matrix. Anytime we have an undirected graph, we'll always get this symmetry about the diagonal. You could ask yourself on both of these graphs why the diagonal is 0. Here, this is all 0 here. And the reason why is because for our purposes, we're not allowed loop backs. Like, here, I'm going to do one up here. Like that. We're not allowed that. If I'm at vertex 1, it doesn't cost me to stay there. So what does that mean? I'm not a helicopter. For a helicopter to stay in one position, there's a cost. But not for me. I'm a person sitting in a chair. It doesn't take me any energy to stay where I am. Okay. Let's try one more adjacency matrix. We're going to do it a little bit smaller. 0, 1, 2. I'm going to go from 0 to 1 and 1 to 2. And let's see. I'm going to do one like that. Alright, so now we're going to test our thing that we talked about up here. We should be able to see a symmetry about the diagonal. So let's do it one more time. Zero, 1, 2, 0, 1, 2. Okie dokes. If I mess up, it's your fault. Okay. 0 to 1, I have a connection. 0 to 2, I have a connection. 1 to 0, I have a connection. 1 to 2, I have a connection. Let's see. 2 to 1, I have a connection. And 2 to 0, I have a connection. Doggone it. It's worked out just like the last one. Anyway, you can see I again have a symmetry about my axis. Let's see. 0, 0, 0. Telephone ringing. Sorry about that.